Okay, so let's now move further about the covalent bond, ionic bond. So now what I'll do in this lecture number 19, is I will give maybe more detailed examples about the covalent bond and the ionic bonds. Okay, so now let's take the example of again of the potassium iodide. Now, if you guys remember, potassium belongs to group number what? It belongs to group number. Can you guys think about? If you don't know, you can go to the periodic table on page 500 and try to figure it out. But potassium belongs to group number 1. And iodine is like chlorine, it belongs to group number 17, so it has 7 electrons at the outermost shell. So the potassium has 1 electron at the outermost shell, but the iodine has 7 electrons at the outermost shell. So both of them are not stable, as we mentioned in the last lecture. So the potassium wants to give away 1 electron, and the iodine wants to gain this 1 electron. So they make an ionic bond, right? So as you can see, the potassium turns into a plus ion and the iodine turns into a minus ion, right? And if you check the electron dot diagram, you see before the compound is being formed, the potassium is having only 1 dot. It means it has only 1 electron at the outermost orbit, while the iodine has 7 electrons at the outermost. So it means that it has 7 dots. So it means that it has 7 electrons at the outermost orbit. Now the potassium loses 1 electron. Now you can see no dots, and the iodine gains 1 electron, so you can see it has now 8 dots at the outermost orbit. The potassium turns into a plus ion, the iodine turns into a minus ion, and they make the potassium iodide Ki. Now there's another example here, which is the magnesium chloride. And if you guys remember that magnesium belongs to group number 2, so it has 2 electrons at the outermost orbit. Now, 2 electrons, it means that again it's not stable because it must be 8 electrons to be stable. That's why the magnesium wants to get rid of these 2 electrons. So the magnesium will go to the chlorine and it says, hello chlorine, I hear that you need some electrons. I have 2 extra electrons, can I give it to you, chlorine? The chlorine will say, no thank you, I cannot take 2 electrons, I can take only 1 electron. And the reason is because I belong to group number 17 and I have 7 electrons at the outermost orbit, so I can take only 1. That's why the magnesium will make a deal with 2 chlorine atoms such that it gives this one 1 electron and it gives that one the other electron. Now the magnesium loses 2 electrons, so it turns into a 2 plus, and each one of the chlorine gains 1 electron, so it turns into 1 minus. So that's why we have MgCl2, right? Because it uses 2 chlorine atoms and only 1 magnesium atom, or it takes 2 chlorine atoms and 1 magnesium atom to make the magnesium chloride. Okay, now we have to look at the electron dot diagram, and you will notice that before making the compound, chlorine has 7 dots and magnesium has 2 dots, right? Now after making the compound, the magnesium will have no dots. It means that the outermost orbit is completed, while the chlorine, each one of them is having 8 dots outside. It means that it's also now satisfied, it has its outermost orbit complete. Okay, now let's memorize or refresh our about what we have, our memory about what we have learned in the last class about the covalent bond. And we said that the covalent bond is happening, for example, in the water molecules. And we said that the oxygen is having 6 electrons at the outermost orbit because it belongs to group number 16. And it needs to share 2 electrons with 2 hydrogen atoms, such that the oxygen feels that it has 8 electrons at the outermost, and each one of the oxygen feels that it has 2 electrons at the outermost. So if I do counting here, I will see that the oxygen is having 2, 4, 6, 8, and each one of the hydrogen is having 2 electrons at the outermost orbit. Perfect. Now this kind of what we call it sharing electrons. Okay, now I want you to understand something important here, that when we do sharing, when we have electron sharing, then I call this bond the covalent bond. I call this bond the covalent bond, and the covalent bond makes molecules. So I for example I don't say water compound, I say it's a water molecule. But for NaCl, this salt, I call it a compound, right? So usually with sharing, we call it a molecule. So now the covalent bond could be one of three things. It could be either a single covalent bond, or a double covalent bond, or a triple covalent bond. The covalent bond again could be either what? Single or double or a triple covalent bond. Okay, now what does that mean? A single covalent bond means that only one electron is being shared between the two atoms. And a double covalent bond means we have two electrons that are being shared. And a triple covalent bond means what? We have three electrons that are being shared. Okay, so I have a single covalent bond, a double covalent bond, and a triple covalent bond. Now, let's take some examples. Now, look at the oxygen, O2. Now, again, oxygen belongs to group number 16, so it has 6 electrons at the outermost orbit, and for this to become stable, it must be 8. So if the oxygen decides to interact with another oxygen, then both of them must share 2 electrons here, right? Must share 2 electrons, and this will make it a double covalent bond because 2 electrons are shared by each atom. Now, what about the nitrogen? Nitrogen belongs to group number 15, and it has 5 electrons at the outermost. Now, for this to become stable, it must be 8 electrons, right? So if nitrogen decides to interact with another nitrogen to make the nitrogen molecule, then there must be 3 electrons that are being shared, right? So that's why I call it triple covalent bond. So let me emphasize here about, if I say it's a double covalent bond, it does not mean 2 atoms are combining together to make the molecule. It means that the atoms are sharing 2 electrons each. So this double, it means the number of electrons that are shared, not the number of atoms that exist in the molecule. The same thing, if I say nitrogen N2, this makes a triple covalent bond. That does not mean that we have 3 nitrogen atoms. It just means that each nitrogen atom is sharing 3 electrons to make this molecule. Okay, so I hope this is clear. So we have the covalent bond could be either a single covalent bond, or a double covalent bond, or a triple covalent bond. Now remember from last class we talked about the covalent bond, and we said that the covalent bond is happening because atoms share electrons between each other. Now, I want to think about this example. Now, let's say, for example, that you and your dad are sharing a car. Now, let's say that your dad or your uncle just bought a brand new expensive car. Let's say, I don't know, 2020 Lexus or a Bentley. And then you say, oh wow, this car is so nice. And then he tells you, don't worry, son, I'm sharing this car with you. This car is for both of us. We are sharing this car together. But what happened is your dad or your uncle ends up using the car for 7 days a week, and he gives it to you for 20 minutes to clean it or wash it, for example. You see, this is a kind of sharing, but it's unequal sharing. It's unequal sharing. And why it's unequal? It's because he is stronger than you, because apparently he is the one who paid for the car. So that's why he's using the car more time than you. You see, so this is a kind of sharing, but it's unequal sharing. Now, can this unequal sharing happen in chemistry? And then yes, Look at this now. Look at these two atoms, chlorine and hydrogen. They share electrons, right? They share one electron between them. But look at this. This is the uncle or the dad, and this is you. You see, this one is much bigger than this one. So that's why, although they are sharing this one electron, but the electron spends more time with the chlorine and less time with the hydrogen. It spends more time with the chlorine and less time with the hydrogen, right? So that's why a negative charge appears on the chlorine and a positive charge appears on the hydrogen. So we say that the chlorine becomes partial negative and the hydrogen becomes partial positive, right? And we call this molecule a polar molecule. So the word polar means what? Means so a partial positive and a partial negative charge appears there. Now remember, this negative and positive charges are not happening because of gaining and losing like in the ionic bond. That's still sharing, as I mentioned, but it is not equal sharing. It is unequal sharing. That's why one of the atoms will have a partial negative charge appears on it, and the other one is having a partial positive charge appears on it. Now the same thing could happen in the water molecule. The water molecule, as we discussed this class and last class, is also a polar molecule. Now why? Because yes, although oxygen and hydrogen are sharing electrons, but the oxygen is much bigger than the hydrogen, so the electron will stay more time with the hydrogen and less time with the oxygen and less time with the hydrogen. So a partial negative charge will appear on the oxygen and a partial positive charge will appear on the hydrogen, and they make this polar molecule, which is the water molecule H2O. So now I want you please to know four important things. Now one of them is called equal sharing, and then I have unequal sharing. Then I have something called a polar bond and something called a nonpolar bond. So equal sharing will happen if the two atoms are similar to each other, like oxygen, oxygen, nitrogen, nitrogen. That would be equal sharing. It will be the same as you share a car with your brother or with your twin brother. Now he cannot take more time than you. He uses the car for 3 hours and you use the car for 3 hours, right? He cannot take more or less time than you. Because both of you are having the same strength, right? Now this will make a non-polar bond. So the equal sharing produces a non-polar bond. But the unequal sharing, like for example in the chlorine and the hydrogen or the oxygen and the hydrogen, that gives me a polar bond. Okay, so well, let's repeat this one more time. So I have equal sharing, unequal sharing, polar bond, a non-polar bond. The equal sharing produces a non-polar bond, and the unequal sharing produces a polar bond. An example of equal sharing and a nonpolar bond is O2 and N2. An example of unequal sharing and a polar bond is the H2O and HCl and so on. Okay, now the next and last thing here is we need to emphasize that sometimes molecules are polar not because equal or unequal sharing, but it's because of the geometry of the molecule. It's because how the molecule could look like. Like for example, here we have something called the carbon tetrachloride and CCl4, carbon tetrachloride. Now this molecule is a non-polar molecule. So what I want you to do is I want you to memorize this name, to memorize the symbol, and also to know that it is a non-polar molecule. Now why it's non-polar? Not because of equal or unequal sharing, it's because of the geometry. Because if you look carefully here, you will see that the chlorine is surrounding the carbon from all sides, so that doesn't give the chance to have pluses and minuses, so that makes it a non-polar molecule. But in the other molecule, which is a trichloromethane, CHCl3, again you need to memorize the name and the chemical symbol. This one is a polar molecule. And why it's polar? Because again of the geometry, because the chlorine stays at one side of the molecule and the hydrogen stays on the other side. So that's why we have pluses and minuses. That makes the molecule be a polar molecule. Okay, so please know that there are two different ways for molecules to be polar or non-polar. One of them is from equal and unequal sharing, The other one is because of the geometry of the molecules, and we will try to talk more about this in the next classes, inshallah. Okay, so I guess that's all for me for today, and I hope you guys now are more familiar with the covalent bond, the ionic bond, equal sharing and equal sharing, polar and non-polar. So all these are very important definitions for us to understand. And thank you so much for watching this. We'll see you in more classes soon, inshallah. Thank you.